Hello, Professor. Welcome to Proj.3 Project 3 Demonstration, as it is showing on the notepad. So the first thing, let's begin to run my project on my device, as I deploy first. So let's go to the screen of my device. Install first. And the first time you run, it will ask the permission for the video, and we press allow. Although I allow the permission, but the OpenCV checks the permission first, so we just need to restart my app.
6 cats, 3 cats, 18 cats, 18 cats, 18 cats, 11 cats, 15 cats, 12 cats, 20 cats, 21 cats, 14 cats, 18 cats, 16 cats, 12 cats, 14 cats, 17 cats, 14 cats, 12 cats, 14 cats, 18 cats, 15 cats, 12 cats, 14 cats, 15 cats, 14 cats, 14 cats.
I just mute my app. As you can see, my app, it can figure out the cat, and it's based on the cascade classifier. And after it figure out, it will tell you the total number of the cat on the screen. But it's based on the frame, so there will be a problem because, as you can see, it's not smooth enough. So the text to speech will have a delay between the actual what you have seen and what you have heard. And another feature I have implemented in this is, despite I using the cascade classifier independently, I use the combination of cascade classifier and camshift. As you can see, for now, the cascade classifier is a red box, and I use the cascade and camshift together and make the box as a green box. So let's go to camshift and the cascade. As you can see, it's less accurate than the just cascade.
9 cats, 12 cats,
And
8 cats.
forgot about that voice. That voice is just on the queue of the between the cascades speech queue, not this one. So actually, it's crashed. So forgot about that. So actually, the camshift and the cascade filter is based on the I have to detect. So let's go to the code. I have to detect the cascade first. In this case, I can define the shape of what I shall trace. And after I trace it, and you can see I create a list, and if the list is empty or the time has passed more than the time threshold, and I set the time threshold to 10 seconds. That means if there is nothing to recognize or the 10 seconds passed, then the cascade classifier will redefine the shape of what shall be traced. And after that, it depends on the camshift. So let's go to cascade first. In cascade, you can see the first thing first is to convert it to a gray, RGBA to the gray. And I just say cascade classifier and detect multi-scale. But where I initialize it is on the class constructor. as you can see here, I define an input stream, and for the RES and for the raw data, there are two raw data here, and those are all the pre-trained higher cascade. And the first thing first is to read those files, or just one file, into the black box of the Android virtual machine, and then recreate a file called cat.xml, and read everything from here into the cat.xml. And after that, we can say here is the cascade file, and here we can say, oh, get your absolute path, and we want to use, actually we are using the cat.xml. And let's go back to the cascade. So I just say detect multi-scale here, and here are some threshold value. That means the two object I recognize is not more than 2 in some small space, and for here the minimum cat face I can recognize is not less than 100 times 100. So that means something very small I will just ignore. And you can see there is another variable called cam_info_list. Cam_info_list is just an array list, same the cam_shift_info. The cam_shift_info is another class I have implemented here. It is just a data storage class. It stores the rect and the histogram of its in cam_shift_info for just one thing you would like to trace, because as you can see from my example, there are various of frames I would like to trace, so I need a list to store all of them. And this is just a list, and I implement it as an array list. And the first thing is that once you want to renew your frames, so the first thing is to clear all the previous one, and for every rect you have detect, just means for every frame you have detect, and you need to calculate the cam shift first, and after that draw the result on the frame, just and you can see here is a red frame, and then speak the total amount of it, and this is a Google API is called text to speak class here, and I just initialize it to the set language to the US, which is definitely is in English. And let's go to the calculate cam shift. For the calculate cam shift, the first thing is just I have an RGBA picture at first, and I want to I don't need all of them, so I just need a little. I just need what things inside the window. That means the things I want to trace, and that is an RGBA picture, and I can convert it to the HSV, but there is no obvious way to convert RGBA to HSV directly, so I have to convert to BGR first, then convert the BGR to the HSV, and you can see finally it stores in the variable called HSV. And after that, I calculate its mask value and split its HSV into the various into separate channel. The HUE is just means separates HSV into single channel, and this is a list of mat. And after that, I just calculate the histogram of it and store it in the variable hist, and make a normalize of the hist. And after that, I store the rect and the hist I have calculated into the cam info list, as I mentioned here. It's a cam shift info list. And let's go back here. So that is one frame of cascade. After that, let's see the Android monitor. If there is something I can see or not, or no. Just say as I record, for each frame the cascade will take about 2 seconds, about 2 seconds to execute one frame. So that is very slow. So that is why I want to use cam shift, because it's pretty fast. And so I use so in another 8 seconds I use the cam shift to trace it. So that will lower the CPU utilizations. And let's go to the cam shift. Cam shift here. Here is I just input the RGBA color image, and I just make another HSV image, and I calculate this time for each frame in the list. I want to calculate each of their cam shift value. So there is a for loop, and the first thing is that I calculate the back project, and after I have that value, I can do the cam shift. And after I do the cam shift, I have a new frame position, and I restore their position to make it inverse and save its value into the list. That means update the list, so for the further use. And after this thing's done, I just draw that frame on the picture. And that is about the cam shift. As you can see, there are another method is called cam shift, and cascade 2, and draw rectangles. Some of them are used, some of them are not used, but basically this is all the works I have done. Like this draw rectangle, I just try to replace the rectangle with the JNI Java Native interface to my own implement interface. But I tried this method, but I found there is little help for reduce the execute time for both cascade and cam shift, because as I concerned, the mainly process time for the cascade is in this sentence, detect multi-scale. That spend so much time on it. Despite for direct there are only several, not more than 20. So no matter 20 JNI call or 1 JNI call, it will not affect much like we have done in the project 2. And for the cascade 2, that is another method I have implemented as a cascade classifier separately. As you can see, for the difference between the cascade and the cascade 2 is that I didn't calculate the cam shift on the cascade 2. I just set another counter and use the counter instead of the size of the list to say there are how many cats here. But basically they are the same, because for one rect you have a frame, and that is accurate basically. And for the cam shift here, this part of code is another try of my cam shift algorithm, because I tried to let my cam shift works well as I desired, but I failed. It may crash, it may not recognize well, whatever, but basically it just not working as I expected. And for further things is let's go to the main activities here. You can see I have to initialize my algorithm class in the onManager connected before I can initialize in the onCreate, because this thing is the first. This thing is the later things will be initialized. So if I initialize all my algorithms in the onCreate, that means before the application loads the OpenCV libraries into the apps, I try to use the library. Where to use? No way. It will make my app crashes. And another thing is here. This sentence is about the ask permission to use cameras. And later things is that I have a spider manual, though it is like invisible. So that is all about my project 3. For me, I have implemented the cascade classifier fine, but not perfect, because that cascade is trained by somebody else, and I cannot control its recognize rate. If I set the size too small, like here, if I don't define the size, that will lead a problem. Is you may recognize some little things that definitely is not a cat face, and it's horrible. So I will try to train some data by myself after this class, and that is about the cascade classifier. And another thing is about the cam shift algorithm. The cam shift algorithm looks simple, and it runs simple, because for each frame it only takes about 20 milliseconds per frame, rather than cascade 2000 milliseconds per frame. Is like very faster than the cascade. But though it seems very easy to implement it, actually I have met a lot of questions. One thing I know is that this code is to keep it from crash, because one thing is that once I recalculate the new boundary, new frame, and the frame is get to a negative number, or set is his y's or x y points to a 0 point, and that is something the OpenCV will not accept. And I try to fix this bug, and I try to learn how to use the cam shift correctly. Although I clearly know the algorithm after the cam shift and each step what I should do, but I keep the cam shift not working as I expected. So that is a pity. And I will try to figure out how to use the cam shift correctly. That's all. Thank you for listening my Proj.3 demonstration. See you, Professor.